Let's now apply the distance formula to get the perimeter of a triangle on a graph. And you can see here we have such a triangle, and its vertices are A, B, C. And we're going to get the length of each side and then add those lengths up. So let's first look at this length AC, or this side AC. And that side right there is the hypotenuse of a right triangle. And I'm going to go ahead and draw that right triangle. It's a long, skinny right triangle. It looks like that. And that horizontal length along here is 13 spaces. And you can get that result by noting that 5 and -8 have a difference of 13. So I'm going to put 13 right here. And then this other length of this right triangle is 1. You can see that visually very quickly, but it's also the difference between 6 and 7. So that length is 1. And if we run those two numbers through the Pythagorean theorem, we get the length of the hypotenuse AC. So AC is the square root of 13 squared, 169, plus 1 squared, or 1, which is the square root of 170. Now I could turn that into a decimal right now, but I'm going to keep it exact because I'm going to add other values to that when I get the perimeter. Let's now do a similar calculation for this length AB. Just like before, I'm going to draw a right triangle from A to B so that A and B, or that length, is the hypotenuse. So it will look something like that. And this horizontal length right here is the difference between -3 and 5, which is 8. You can also see that by counting spaces. And then this vertical length is the difference between the y coordinates, -5 and 6, which is 11. And if you run 8 and 11 through the Pythagorean theorem, you get the square root of 64, which is 8 squared, plus 121, which is 11 squared, which is the square root of 185. And just like before, I'm not going to simplify that yet. Let's now get the length of the third side, this side BC along here. And just like before, I'm going to draw a right triangle. So I'm going to come across and then go all the way up. And those lengths, this horizontal length along here is the difference in the x's, -3 and -8, which is 5. And then this vertical length right here, this other leg, is the difference between -5 and 7, which is 12. So that length is 12. And if I run those numbers through the Pythagorean theorem, I get the square root of 25, which is 5 squared, plus 144, which is 12 squared. And that's the square root of 169. And that happens to be a perfect square. It's 13, so I'm going to go ahead and simplify it to be 13. We now have the length of all three sides. We have length AC, we have length AB, and we have length BC. And all we have to do is add them up to get a grand total. So here we'll turn to our calculator, and we'll type all of this in at once on the calculator. The square root of 170 plus the square root of 185 plus 13, and that rounds to the nearest hundredth, 39.64 units. And that's all there is to it.